Okay, so for today's problem, I'm gonna be doing another really quick, easy physics problem that you probably learned before, but I'm gonna go over it real quick. And it's a problem where we don't use numbers, where we plug into a calculator. We solve everything with equations and concepts and ideas. For instance, you find in the end what the fraction of initial kinetic energy that was lost, which is a number that has nothing to do with plugging into a calculator. Okay, so this problem, it's a one-dimensional non-relativistic collision. It's a two-mass particle with an m-mass particle. This guy's moving, this guy's at rest, and in the end they stick together, and you want to find what the loss is in terms of the initial kinetic energy after the collision. But it's lost during the collision. That's the big thing. Okay, so what type of collision is this? It's an inelastic. So what do you know about inelastic collisions? Well, in this case also, there's no net external force acting on the system, which would mean there would be a change in the momentum, but in this case it's zero. So this means the one-dimensional linear momentum is conserved. And elastic, this means the change in kinetic energy does not equal zero, which means energy is not conserved in this case, and there's no potentials here or work by a force. So we know these, and we know these. And because we know, based off the problem, it's inelastic. And I don't believe I know how to spell it correctly, but that's how I would say it. Alright. So how do you go about solving the problem? Well, you got two mass with some speed colliding with mass with no speed. It goes into a situation where they're together, stuck, moving with some VF. Now, how do you get the initial kinetic energy? Well, you will want to first be able to find what the VF is in terms of VI, and you can do that using the fact that your momentum is conserved. And we set that up by knowing we know momentum is equal to, in this case, linear m times v. So what do? You do it here. 2m times vi plus 0 is equal to, so you get vf is equal to what? 2 over 3 vi. So that would be right. So now we use this, and we know that this guy's the only guy that's moving, to get the actual kinetic energy part. Alright, so the kinetic energy part, we know it's not conserved, so they're not equal to each other. That's why they're asking you how much is lost, because there was some kinetic energy lost in the collision. So kinetic energy in general, though, is equal to some mass times some velocity squared, and this is multiplied by 1/2. So, in the initial case, you only have this guy moving, so it's 2m over 2 times vi. So you know that. Or you can write it like this. So one of these is equal to one of these. That's another way you can write that. So one mass times the velocity of the initial one squared is equal to one of the initial kinetic energy value, like the units. Like one of these is one of those. And so we got this guy in terms of VI, so we can use this relation and compare them. So for the final kinetic energy, some energy was lost, and it ends up being 1/2 times the mass So you know, so we're not, what's the mass in the end? It's 3. 3M. Alright. Now times the speed. And again, 2/3 VI squared. So you get 4 over 2 and 3 over 9. So you get 2 over 3 M VI squared. And then you can easily tell you had 1 unit of kinetic energy in the beginning with this relation, and we now have this kinetic energy in the end. In terms of the same, you could say unit or dimensions are said. And we know 1 MVI squared is equal to 1 that, so you basically just minus them and see how much was lost. And you can basically tell, oh, 1 minus 2/3, so that's how much was lost, because it went from 1 to 2/3 of the initial kinetic energy. Okay, just remember, once you know this, you can apply this stuff, and the rest will come. And you have to probably know linear momentum and kinetic energy in terms, mass and velocity. Alright, have a good one.